doing, everyone? People at the back can actually hear me?
Yeah.
Yeah, okay, good. Alright, so first off, does anybody know what this is? Yeah, it's a Saab. Yeah. So there's a couple of things I know about Saab. You don't see as many around as you used to, because the company doesn't really exist anymore. One thing they were known for was engineering perfection. So they like to do everything themselves, to the point that when they were bought by General Motors before their demise, they kind of declined to use General Motors' sat-nav component. Instead, they said, no, we can build a better one, and built it themselves. Anyway, the end. Fast forward to the end, and the company doesn't really exist anymore. You might have already seen this picture before, especially if you've seen any of Simon Wardley's talks. But this is a project created by Thomas Thwaites, who decided it would be an interesting exercise to see what it would be like, instead of going into Argos and buying a £4 toaster, to try and build one from scratch with raw materials. So he went to old abandoned iron mines and mined his own iron ore and smelted it. And eventually, after 9 months, he produced this fantastic toaster with his own plastic and everything. And he plugged it in, and it cost around £4,000 to build or something. He plugged it in. It warmed up for a second, then kind of set fire to itself and melted. There's a couple of lessons there that are particularly relevant for us as software developers, and I'll get to those later. Just a little bit about myself first. So, my name is Eoin Shanaghy, and I'm the CTO of a company called fourTheorem, and we're a professional services company. We don't have any of our own products. We just work with other companies and help them to build, next generation cloud architectures. So we've got we build kind of varying different types of systems, but typically it's we've got a couple of specializations, serverless being one and machine learning being another. And we've got an office in Cork where I'm based, and we've got people around the world because we're a remote company. We also have an office in New Jersey in the States. Myself and my co-founder, the CEO, Peter Alger, we're also writing a book which is available in Mani. There's a 40% discount code there as well, and there's also, I've got a couple of free discount codes for the book. The topic of the book is building serverless AI-enabled applications. So if anybody's interested in having a look at the book, go up to me, I'll give you a free code, and you can use that code for any of the Manning titles, because Manning do that kind of thing for us. So I want to talk a little bit about the evolution of software. I mean, throughout my career, I always kind of felt that we're kind of in the Stone Age, we're in the early stages of evolution as an industry and as a profession. When I started my career, I was building systems in Java and CORBA. There wasn't really a huge amount of open source. The number of frameworks and libraries and tools you had to build large enterprise systems was very thin on the ground. So we kind of had to build everything ourselves. So, if you wanted to communicate with one part of the network to another, you might design your own web protocol and implement that. I actually quite like that, because I suppose I was naturally more of an artisan than a professional software developer, and I just like coding, right? And for me, the more code I wrote, the better I was doing. And over the intervening years, I built a lot of stuff myself from scratch, and was part of teams that built a lot of stuff from scratch. So I built an e-commerce platform from scratch before you could get one off the shelf. I'm sure a lot of you in the room have built user account management, authentication, and authorization systems a couple of times over. Built CMSs, built a web browser at one stage, built an ORM from scratch, and actually built, as part of a team, an enterprise application server in Java. It's all good fun, right? Building all that stuff from scratch. It's an interesting thing as a hobby. In the professional world, I kind of eventually realized an uncomfortable truth about building all this stuff from scratch, as kind of often by the time you built these things, they were more or less kind of ready, just a little bit like Thomas Thwaites' toaster. They kind of looked like what you were intending at the beginning. But by the time you built these things, they were more or less kind of ready, just a little bit like Thomas Thwaites' toaster. They kind of looked like what you were intending at the beginning. But by the time you built these things, they were more or less kind of ready, just a little bit like Thomas Thwaites' toaster. but often the market had passed you by, and these things were kind of available off the shelf anyway. And there was a kind of a harsh lesson in there for me after spending 3 years building this application server, when customers had kind of given up waiting for the next version of the software. We released it with fewer features, more bugs, and worse performance than the version they'd seen 3 years previously. So they decided to move to the competitors, and the business decided that the easiest solution was to shut down the project and just buy the competitor instead. So after this kind of realization, I began to realize that, layers of abstraction and taking advantage of third-party platforms that do all of this for you is a good thing. Because ultimately, you don't get much satisfaction as a developer if your products keep ending up on the shelf. You need to see them out in the real world, right? And over the years, we've seen stuff we used to have to be responsible for as developers being taken over by the cloud providers and service providers. We've been able to see the advantages, no longer having to rack and stack physical machines. Then we were able to use virtualization. From that point, we went into containerization. All of this stuff gave us much less surface area to be dealing with as developers, much less complexity. And we can see that moving forward now as more and more of all of this stuff is just being commoditized. So just like the components in the automobile industry or a toaster in Argos for £4, all of this stuff that we used to deal with is just becoming commodity. And that's a pattern that you see repeating over and over again. And it's an interesting one for developers and for architects, because you kind of have to look forward and see, what are we building today that's going to be commoditized tomorrow? And I feel, the last kind of 5 years in particular have been particularly exciting, because I think something kind of fundamental has changed. It's not just step change, but with what I would call the microservices era, we've had this confluence of, product first thinking, like don't just build the product right, but build the right product. We've had kind of open source collaboration enabling us to work faster. The actual containerization and building smaller units and as microservices, it allowed us to actually finally do continuous deployment faster. It was a lot more difficult before with larger systems. And because they're distributed systems, you had scalability. Because of the cloud, you don't have barriers, right, to getting things into production fast. But especially at the early adoption phase of microservices, as with any new technology, there's the amount of tooling and resources available to you to get that stuff into production and do it right are fairly thin on the ground. So a lot of people ended up with the effect where you have to kind of build tooling, build infrastructure, build orchestration software to manage that. It's kind of like building your own paths. We saw that happening at Netflix. I'm sure a lot of people here who were involved in microservices feel that too. You get a lot of the benefits, but you trade a lot of you trade complexity of the paths for a new kind of complexity in managing all of that. But I think that's now been commoditized in the form of serverless. So it's another step towards commoditization of infrastructure for deploying software that's represented as a very small unit. So this is like to move towards really true utility computing, where you can really turn things on and off as you need them. Basically, the trade-off is you hand off more and more responsibility to your cloud vendor, and you get much faster development time and less code to write. So, serverless is often synonymous for a lot of people with functions as a service. I tend to kind of shy away from that, really, because I think it's a lot more than that. It's really about understanding all of the things that we are building into our platforms on a daily basis that are being commoditized. So it's not just about Lambda. In fact, the goal, if you focus on Lambda and functions as a service, you're still really focusing on the code you're writing, whereas the real advantage of serverless is the code you're not writing. So then what are the major challenges? And there are a lot. I wrote a blog post about this stuff recently, because with the hype cycle, with these new waves of technology, the positivity can be a bit overbearing, right? And when you're working in an existing organization with an existing technology stack, and you hear, you're reading, serverless is the new form of computing that's going to change how we build software. It's a bit like, what now? I just learned how to Kubernetes, and now I got to deal with this stuff. So you have to. It's logical to ignore it for a certain amount of time to see let the dust settle. But if you look at the pattern of commoditization, you kind of have to eventually figure out, okay, how do I adopt this? What does it mean for the organization? How does it coexist with what we already have? There's a lot of questions there, and it's just adopting serverless is not simple. Like if you take a case of trying to build an application in AWS using serverless best practices today, it's actually pretty complex. There's a learning curve with all your cloud resources. All that power gives you a lot of responsibility, but also a huge number of options. So you've got decisions to make, you've got to experiment, figure out what the best way is. How do you do continuous deployment? How do you structure your project? How are all these systems going to communicate with each other? How do you tie them together? So again, you're kind of trading for different form of complexity. You've got all these loosely coupled pieces. How do you reason about that? So we've been through this a couple of times in our company, and we've built a few serverless platforms for people. And as we do it, we get better and better at it, hopefully. And there's a lot of kind of best practices we build up. And so for ourselves, when we go into a new project, we want to kind of take those and get going quickly. So we decided, as a solution to addressing all of those problems with the fact that if you just adopt serverless today in your organization, you could be going down rabbit holes, trying to get it working. You make mistakes, you have to iterate, really kind of find your footing before you're in a place where you've got something small, stable in production. We decided to put it all together, and rather than building a framework, which kind of requires a lot of buy-in from people, we decided we just create like a complete example production application. What does a complete serverless production application look like? So it's a starter application. You could clone it, have a look at it, learn from it. You can deploy it if you want. You can use it as a starter kit for your own project, but there's no obligation to rely on any framework and version follow it or anything. It's really just a learning resource and just an accelerator to get you up and running quickly. And another thing about it then is that we wanted to kind of show it in its full production mode, right? So it's continuously deployed publicly to the internet, to a website, from the GitHub open source repository as well. The project is called Slick Starter. The goal is to kind of get you to a state where you have a production grade application in a day. A lot of example tutorials when you're learning new technologies, you can spin up very quickly, you can run it in 30 seconds, you have something up and running. This has quite a lot of features in that it touches all of the kind of areas you will need, and hopefully then avoids all that pain. So just to go through some of the things it'll give you then. So project structure, okay, how do you structure your projects, lay out your folders, repositories, that sort of thing. In our case, we went for monorepo structure, but with each service being continuously deployed separately in an independent pipeline. So then we've got continuous deployment, and as you add services to the application, it will scale out with adding automatically new pipelines for you. So it's got centralized logging. I'll go through these in a little bit more detail in a minute. Security in terms of permissions, access control, monitoring, something we want to kind of build out more. And local development is a massive one in serverless. Like if you're going all cloud native with AWS, a big problem is, how do you avoid slowing down your development? Like one of the fantastic things I loved about Docker was that it gave you very fast ability to have a local development environment which mirrored your production environment. If you move away from Docker and into Lambda, then you lose a lot of that actually. So you've got to figure out how are you going to work around all of that. So we've done quite a lot of that, and we're improving it all the time. We've got a suite of API tests and end-to-end tests. We also provision DNS, so by default you're assuming it's a production public SaaS type application, so it'll provision DNS for you and certificates for HTTPS as well. So if you can deploy it to as many domains as you want, it'll generate all of the certificates now in the environment. We try to keep the architecture fairly simple, but it's documented. You get an architecture diagram, which you can evolve as you kind of make changes to the application. We try to give answers for like how do you do communication, event bus, messaging between services, all that kind of stuff. Then user account management, sign up, authentication, all of that. Full front end and like data access and APIs. So you'll find on GitHub if you go to this URL, there's also a short URL which is just slick.app. If you go to that URL, there's a button there that'll take you straight to the GitHub page. Okay, so the app itself. So we're trying to figure out what's a simple, easy to understand, but something we can grow kind of SaaS application that we can build and put into production, simulate this real production system, which is quite a challenge really. But the application we have, and you can go to it, it's actually deployed to slicklists.com. So Slicklists is like a checklist management application. So we use a lot of checklists in our kind of business on a daily basis. You're kicking off a new project. What are all the things you need to have in place before you're ready to go on it? You're deploying live to production. What are all the things you need to go through? So we just built a kind of an application that was a simple rendition of that, but something that can get more complex as you add features. So this is like your set of lists here. You can have a look at this in your own time. Anybody can sign up for this. You can go in, create lists, edit them, check off items, that sort of thing. And then as an example of like simple kind of multi-service integration, when you create a list, for the first time, it will send off a welcome, like it'll trigger a welcome. So it'll send you an email ultimately saying congratulations, you've created a list. It's a very simple case, but it's enough to kind of develop out an architecture for how you would do, I suppose, decoupled distributed microservices architecture using serverless. So one important thing to note is that it is AWS only. The reason for that is, okay, well, first of all, we work with AWS a lot. I think it would be fantastic if the community contributed forks of Slick Starter which work with other clouds. But first, to try and be cloud agnostic means, I suppose, building in something that a lot of production users aren't necessarily going to do, right? You pick your cloud generally and you go with it. There's a small minority, I think, of people who have to be cloud agnostic, but in general, once you pick your cloud, you can go with it. So we don't want to let kind of that cloud agnostic requirement get in the way of pushing out new features and building out this application. And then how it's set up. So we use multiple accounts, so it follows the principle that every environment is in a separate account. What that looks like is in AWS, when you're setting up the project right now, from your root account, you go into AWS organizations and you create an account for your staging environment, for your production environment, and you create one for your tooling, your CI/CD, and you use cross-account permissions to kind of isolate access to those environments. And then your CI/CD will deploy into those accounts. In terms of tooling, right now we're using the serverless framework. It's probably the most mature out there. It's something that will probably change over time, though, if I'm honest. It works fine for now, but in terms of being AWS only, I think the advantages of using AWS as alternative SAM will kind of bring a lot of benefits down the line, because it's integrated more tightly into code deploy, doing canary builds or blue-green deployments and that sort of stuff. I mean, ultimately, if you've used CloudFormation already to build, to do infrastructure as code in AWS, serverless framework, SAM and CDK are all built on top of that. So we have started to use CDK, the Cloud Development Kit, which is still in developer preview, but it's a very nice improvement. I might actually show some of that now, actually. Okay, so it's worth kind of showing this, right? Because we're not using CDK for building the application itself right now, and for deploying all of the services, but we are using it for deploying the continuous deployment infrastructure itself. So what we wanted to be able to do, if you look at the structure, I can show it over here. People can see that. Sure. So within Slick Starter, we've got a number of services. Like we've got baseline, which is some common resources. We've got front end, which is front end service. Things like user service, welcome service, checklist service, right? So there's 5 or 6 in there at the moment. You can imagine that scaling out to 80 or 90 services. So what CI/CD does is it's a CDK build pipeline, which allows you to define all of your resources using a programmatic interface. So in this case, we're using TypeScript. You can also use Java, JavaScript, C#, and Python, I think. So what it allows us to do is basically, for each environment we want to deploy to, and for each module, so every service in our application, it'll create a module pipeline. The module pipeline is, your source action linked to code build project, etc. Right? So it's very nice in that you can dynamically build this infrastructure based on runtime conditions. Okay, so then the goal is also, right, when you're going in all in with Cloud Native, is to build all of your deployments. So you don't use Jenkins, you don't use Travis or Circle CI. Let's see how far you can push it and use AWS's code pipeline, code build, and all those good services. And like, to be honest, all of these things have a higher barrier to entry than using Circle CI, right? Because those platforms are way simpler and way more developer friendly. You're trading that for customizability and kind of infinite configuration possibilities you get with AWS. And as well, those tools from AWS are still just maturing. But I think we actually went through a lot of pain figuring out how best to do continuous deployment for serverless. Definitely interested to get people's feedback on it and see how we can make improvements to this. Ultimately, what we do is we dynamically create a code pipeline here, and that pipeline has staging stage, test phase, and then a production stage at the bottom. But because each service is in its own pipeline, these service pipelines in the middle there, they're dynamically generated like by the CDK for each service, and they run in isolation basically. So if you make a code commit to the checklist service, you wanted to package that up, deploy all your lambdas, your API gateways, whatever other resources you have there, and run its unit tests in isolation as well. So how that works, we've got a monorepo, like I said. We use the approach where you've got a code build phase, which gets triggered by your GitHub PR merge or whatever commit you've made to master, and it will do a change detection. So it'll basically use a git diff on the previously released version, find which services have changed, and send that information down to the orchestrator pipeline. So the orchestrator pipeline will say, okay, the baseline and the checklist service have changed, and the front end has changed. You kick off a build for each of those 3 things in parallel. it'll install them, run its unit tests, deploy it, add it to the target environment, which will be staging initially. After that, it'll run from the orchestrator pipeline. So it's basically polling the status of those code pipeline executions, then it runs all the staging tests. Then you can decide whether to move it all into production. Okay, so then in terms of tests, writing tests again is something that you want to get started with pretty quickly on a project. There's always a bit of pain with figuring out your tooling, so we give you a set of API tests and end-to-end integration, end-to-end tests. So we call these API tests integration tests. Realistically, it's integration of all your backend. It's not integration of each service in isolation. So these are like, by the way, I don't think I mentioned yet, all of the services are written in Node.js. Obviously, you can swap that out for your own, whatever language is your flavor of choice. But the API tests are simple node-tap tests that run 8 REST requests with Axios. There's a couple of things like we're using Cognito in AWS for user account management and authentication. We have a kind of a simulation layer for that, which you can use in local development and in your tests as well. Also using Mailosaur, so when like you do signups or when you do like your welcome email, it uses Mailosaur as a kind of to generate email addresses and check the emails that have been received. So you can do that end-to-end behavior. Then on the UI tests, we're using Test Catfish. So that's basically what it looks like in your code pipeline. Those two test jobs are run in parallel. Okay, like I mentioned, local development is kind of an ongoing story, but it's a huge part of it. So I think it's worth spending a little bit of time talking about how we do it. So there's a couple of different layers to it. If you're developing a service, you're writing your node code, you're writing your service. You're trying to separate your Lambda from the actual logic behind it. So you've obviously got like local execution capability there. You can run unit tests, and that's really how you get your fastest turnaround time in development. Then when you want to simulate the Lambda environment, we use Serverless offline. So that will give you an API gateway Lambda integration and other integrations to trigger your Lambdas in the local environment. That's just for one service, right? We also use local stack. So local stack is Dockerized simulation of many of the AWS services. It gives you, like, there's a pretty extensive range it supports. Cognito is not one of them, just why I mentioned that we have to do kind of a mock Cognito kind of behavior where you can log in with any email address, but it'll still create the right payload that the offline backend will be able to understand in order to be able to tie your session to data at the back end and figure out which user you are. So in order to be able to facilitate, like as your services grow out, running multiple ones in your development environment, if you don't want to be constantly deploying to the cloud, like a lot of people do write Lambda functions with API gateway and deploy to the cloud as part of the development workflow. I find it's very poor experience for just developer flow, for getting instant feedback, and for, I suppose, yeah, just focus and concentration in general. It's quite disruptive. You know, you're waiting a minute or two before your Lambda is live. So what we do is we use a tool called Fuge, which Peter, we mentioned earlier, developed, and I think he's spoken about it at this meetup before. But it's for running, multiple microservices in a development environment and managing all of those processes, and it integrates to Docker as well. So you can bring up your Docker containers for local stack. You can bring up all of your services and work with them locally in a development environment and get a very effective simulation of your AWS backend. Okay, user accounts. I mentioned we're using Cognito user pools. We also use the Amplify SDK, which does all of the client-side sign-up, authentication, confirmation, and it also provides you with an authenticated execution of your REST API calls. So that's, that's a fun. Like I mentioned, I've built user account management multiple times in the past. I'm sure many of them with serious security flaws, it's fantastic to be able to just, plug that in and kind of replicate it on every project in your way and you have it done. And you can also then extend it. You can take this and extend it to support social login or SAML or whatever other case you have. So just to talk about events. So the principle of kind of keeping it simple initially in our architecture, we're probably going to add in some kind of like event streaming as a core of all events in the application. Right now we actually just use CloudWatch events. So I'll show you the architecture, but like CloudWatch events can be used for not just getting notified about AWS services, but you can use it as a general purpose hub sub. So fire any kind of message into it and trigger your Lambda based on a pattern in that message. That's very powerful. You don't have anything to provision. You can just fire off a message that says message type checklist is created, like a lifecycle event like that, and any of your Lambdas can be triggered off the back of it. Okay, front end is it's a complete front end. It's got its React application at Redux Material UI, so fairly I suppose ubiquitous kind of stack. With the Amplify SDK as a core part of it, and then the front end service itself is deployed to an S3 bucket when you deploy the front end service, and globally distributed then with CloudFront. So we're also, as I mentioned, provisioning the domain and certificate. So like if you've got your domain, slicklists.com or whatever, it serves your application when your continuous deployment is complete. There's also, so one of the complexities in serverless or even in microservices development is dependency management. Like how do you manage when you've got dependencies between your front end and whatever service at the back configures your authentication. You've got something like you deploy a user pool, you need to get the ID of that into the front end. So the build process has support for basically when you're building your front end, it will go call down to AWS with the right credentials, fetch outputs of the backend CloudFormation template, get the user pool, and build that into your front end. What that means is that you don't have any kind of copying and pasting of configuration from one service to the other to configure it. And if you deploy it to multiple environments, all of that is automatically done for you. Okay, so in terms of logging then, centralized logs, we use the Pino node module to capture structured JSON logs, and they got centralized and pushed into logs.io, which is basically Elk Stack managed service. So that's fairly simple. There's a logging service in there. It's got a CloudWatch log forwarder that forwards to logs.io. You can easily replace that with Splunk or Elasticsearch in AWS or whatever other sync you're using. I'm not sure even from the back if everybody can see that, but you'll see it on the GitHub page anyway. There's a fair bit of documentation in the README. Like I said, it kind of takes, if you wanted to actually deploy this into your own AWS setup, it's not something you do in half an hour because you've got to configure domains, you've got to wait for DNS propagation, you've got to verify certificates, verify for email domain. So the kind of stuff you actually have to do if you want a real application in production. But you can have a look through the documentation, learn from it. And this basically shows like how everything is split out in the actual application itself. All the AWS services that it's plugged into. Like you've got your welcome service here, talks to email over SQS, for example. The other one I mentioned is like your CloudWatch events, event bus. Checklist service is emitting a lifecycle event that says, I've created a list that triggers off this welcome workflow, which interacts with the user service to find out their email address, and then with the email service to send their address, right? We've also got AWS X-Ray configured by default as well, so you've got tracing throughout the application, so you can get pretty quickly service map of all traffic throughout your system, and you can also do then performance and error checking through that. We have a strong desire to kind of add more monitoring capability into it between the logging the kind of CloudWatch events, and that's what we have right now. So in terms of roadmap, like I mentioned, okay, so we've got, I suppose, a big list of things, and we'll add to it as we do more and more. Like we're going to keep adding to this repository, and we're starting to get more and more other people involved as well, which is fantastic. One of the things we want to do is kind of help people to get started quickly. Like I said, right now, you kind of have very little between, getting it running on your laptop and, deploying a full 3-account system to production. So it's quite a big leap. So we'd like to have kind of an easy, much faster process where you don't necessarily have to provision the domains, but you can deploy it all to a single account and just get a feel for it that way. One of the most time-consuming things in setting all of this up is getting IAM permissions right. So there's a lot of manual steps and discovery involved in that. So we'd like to see about kind of integrating into some better security automation tooling to make sure we have a more robust semi-auto process around getting all of those permissions right. It's just incredibly important. And then so things like feature branch deployments, role-based access control, kind of user interactions which are more like illustrative of other production use cases like real-time event processing, analytics, that sort of thing. So the call to action then from us is if anybody is interested in this, either like just exploring it, giving us feedback on it, constructive criticism, if people want to get involved, help improve, suggest, like, tell us what your experience is, how you'd like to get involved, contribute code. There's a lot that could be done. I mean, there's another fantastic open source project around serverless called MIDI, which a few developers in Dublin are involved in, I know, but it's something we'd like to plug into Slick Starter as well. So there's a huge amount of scope for a lot of interesting and fun stuff there. So yeah, that's it for me. Thanks very much for coming and for listening. I'd encourage you to, like, if you want to follow the progress of it, keep an eye on it. Follow me on Twitter. We've got a lot of blog content around all of the principles as well, kind of breaking down each of these pieces, going into them in more detail as just kind of learning resources. If you want to have a look at the book, that's the URL for the book is servicebook.com, and then the repo is slick.app. Right, thank you.